Okay, you can hear me, that's good. So first of all, good afternoon, everyone. My name is indeed Łukasz Koczwara, and I'm a software development manager in STX. I work in Wrocław department. And today I would like to tell you a bit about software quality, because before STX I was a quality consultant for over 2 years, and I find this topic very, very interesting. Hopefully after the next 20 minutes you will find this interesting too. I'm really happy also that Paweł Jordeczka earlier today told you a bit about his approach or agile approach, and he also mentioned how important it is to actually see things and to use our own eyes. Okay, so this is how the agenda looks like for today. I would like to tell you at the beginning about technical debt, because we all have to deal with technical debt from time to time, and some of us even all of the time. Then software metrics, because I think that this is the best way to actually deal with software quality. And at the end, I would like to show you some tools. This won't be live tools, but some print screens. I think still okay to take a look on those. So quality goes first, of course. And at the beginning, I would like to tell you a story. So there is a team, perhaps even a team in STX, and they work in Scrum. They have typical sprints which start with the planning session, which is followed by a few days of development and testing. At the end of each iteration, they have feature freeze, they do some regression testing, and they release to production if everything is okay. However, in sprint number 10, something else happened. Just 2 days before feature freeze, like really 2 days before feature freeze, product owner called the team and he told them that, well, guys, actually there is a brand new feature request, which of course unexpectedly emerged from the meeting with product stakeholders, and it would be good to take a look on that feature. So the team sat together, they took a look on the feature, and they got back to product owner with 2 options. The first one was quick and dirty solution, but there was a chance to deliver it on time. On time means, of course, in sprint number 10. And the second solution was clean and smart, but there was no way they can deliver it on time. And because of time, they went quick and dirty in sprint number 10. So they did their job, they delivered everything. By everything, I mean whole commitment from sprint number 10 plus this unplanned feature. And they happily deployed everything to production. In sprint number 11, there was no need for quick and dirty solution. However, the team had to touch some legacy code. And oh boy, what they saw there really made them cry, like really. And it was not okay, but there was no time for tears. And unfortunately, there was also no time for refactoring. So again, they did their job and they happily deployed everything to production. In sprint number 12, they had to change core business logic of their application due to some new functional requirements. And that's what they did. And when they were about to add some unit tests to secure this implementation, key product stakeholder called them and said, hey guys, we have to go live now. And that was the end of the message. So of course they went live because business wants. And if you take a look on what happened within those 3 sprints, you may see 2 things. First of all, some risky decisions were made in sprint number 10, 11, and 12. And second thing, nothing bad happened. Sprint after sprint, they were actually able to deploy everything to production, and no issues were found. But if you take a closer look on what really happened, you will see that they were simply carrying over technical debt from one iteration into another iteration. By the way, for those of you who might not know what technical debt is, this is a nice metaphor, and it's indeed a metaphor. This is not a scientific concept. It was introduced to IT industry in 1992, and I like to explain technical debt as a consequence of cutting corners throughout development. So it's everything you decide not to do because perhaps you don't have time, but later on you never get back to those things. You just leave them undone, and this is the debt you're leaving behind. So in sprint number 10, well, of course, they introduced some consequences of quick and dirty solutions, some technical debt, but they didn't address this in any way. So it was simply carried over to sprint number 11. In sprint number 11, they still had this quick and dirty solution, plus no time for refactoring. In sprint number 12, the same, plus no unit tests because they had to go live. And actually, it's quite obvious, because if you introduce some technical debt to your application, you don't address this debt later on, it's still there. Perhaps covered with dust, but it's still there, it's just waiting for its turn to pop up, and hit you in the face in the most unexpected moment. And I think some of you know this feeling. So we can ask ourselves the question, is it somehow possible to react before consequences will come? I think it is possible. The biggest challenge in managing technical debt and software quality is that time reveals the truth. So all kinds of serious quality issues, they pop up with a time delay. Not after a few weeks, but after a few months. So in sprint number 10, 11, 12, some risky decisions were made, but everything was okay. They were able to deploy to production sprint after sprint. So this side effect of illusion that everything is okay was successfully created. But in sprint number 31, the team realized there are more and more bugs. The code became unreadable. They found a lot of code application, a lot of copy-paste solution because of no time. Development drastically slowed down, and what was most frustrating for them, they were not able to keep up with the release schedule anymore. So each single release had to be postponed due to quality issues. I think this might be familiar for some of you, and this is really true. Time reveals the truth. In life, we like to say that time is a healer. In software development, I like to say that time is a killer, and it sometimes can kill our application. So now I think we can ask ourselves a question, is it somehow possible to react before this cascading effect of consequences will start to kill our productivity and our application? So is it somehow possible to make all of those quality issues a bit more prominent, to see the risk hidden by those depth indicators, because those are depth indicators? And I think there is a way to do this, and I would like to tell you how to do this. But before, we're going to take a look on tooling, because actually the tools can do the job for you. I would like also to tell you about software metrics. I think software metrics is the best and the simplest way to address technical debt and to really make software project transparent in terms of quality. And software metrics are all kinds of metrics which you can extract, first of all, from your source code, secondly, from related BI tooling like Jira, like coverage frameworks, and the third thing is version control system. Actually, the whole ecosystem around your source code. So those kind of metrics. Why metrics? Because metrics allow you to express whatever you're talking about in numbers. If you have a feeling that your code is bad, you can just measure it, and you can put a number next to your code. And then it will be possible to see if this is really important or not. So this is why software metrics. For example, if you suspect that due to quick and dirty solution in sprint number 10, your code became a bit more complex, and there are way too many lines at nesting level 4, 5, 6, or deeper, because this code is really hard to test, and it's really not easy to read. You can just measure complexity of your code. You can measure complexity of this module. You can measure how many lines of code are there at nesting level 4, 5, 6, or deeper, and you can put a number next to your feeling. And this is the best way to convert your subjective feeling into objective view and really see if you should take an action or not. Those are 5 metrics, just 5, which I really like to use whenever I start to do a quality audit, because it's very good to start small at the beginning. You can actually measure everything. There are thousands of metrics, but it doesn't make sense because you can easily get lost. So let me quickly try to explain to you those metrics. First is code coverage. This is a well-known metric, and this will let you see how much of your code base is secured with tests and to which level. So this is a very important information. Second one, nested code. So this will let you see how much of your code base is, for example, at nesting level 4, 5, 6, or deeper. Because in IT industry, we tend to say that code which is deeper than nesting level 4, so if, for, while, for, if, somewhere here, this code is hard to maintain, hard to read, hard to test. Number of test cases, for example, to secure this implementation grows exponentially to the number of nesting level. The next one is code complexity. This is also known as McCabe complexity. This is just a calculation of branch constructs within your code base, and this will tell you where is the logic in your application. Are there single file items which store all of the logic, which are responsible perhaps for too many things at the same time, or is logic nicely distributed over all your code base? Next one is code application. I think it's pretty self-explanatory. It will basically let you see how much of copy-paste is in your code base. And the last one, code leftovers. I mean, it's OK to have some leftovers at the time of development, but probably leftovers should not be a part of production code. And here I'm talking about out-commented code, about out-commented unit tests, about things like to do, fix me, will fix later, etc., etc. When I did quality audit a few years ago for one of the companies in Germany, I found a brand new thing. It was called TSTD, and I didn't know what is this, so I just, get on the call with one of the developers, and he told me that they've introduced a brand new statement, TSTD, and this is called to skirt to delete. Really. They had, I think, 3 or 4 of those. This was a pretty old code base. It was Fortran 77, but still. So quick introduction to metrics. And I think with metrics, you can really take a look on your code. You can really put a number next to your technical depth. And this is the best way to see quality of your project, to really make it transparent. So right now, a bit about tooling. I would like to show you some screens from 2 different tools. The first one is called SonarQube, and I guess you might be familiar with this one. Second one is called Saline. The first one is for free. There are some paid plugins, but the base is for free. The second one is commercial solution. The first one, I have a feeling, is more for developers, team leaders, tech leaders, those kind of people. The second one is for managers, for business people, for CIOs, CTOs, C-executives. The first one is a nice 2D visualization. The second one is beautiful 3D visualization. So let's start with SonarQube. What you can see here is the main dashboard of SonarQube. In this case, this is a portfolio of applications. This is not a single application. And starting on the left-hand side at the top, first thing you can see is scale rating. Scale rating is a Sonar way to tell you how good you are in terms of technical depth. So this portfolio of Java applications and some other applications is rated at B, which is OK, but it's not the highest rate, right? And just next to scale rating, you can see the ratio of technical depth, and you can see the real technical depth, which in this case is 51,000 of days. So this means that one developer would have to spend approximately 50,000 of working days to fix all of the issues which were discovered by this tool. Just below, you can see real amount of issues, which is approximately 1.8 million of issues, and nice distribution into blockers, criticals, etc. At the bottom, you can see a pie chart, which in this case is configured to present lines of code, real lines of code, so without comments, without empty lines, etc. And this is a nice way to present to you at a glance which application in your portfolio is the biggest one. But this is just a widget, and you can configure this widget in any way you want, so you can actually assign any metric you want to this pie chart. On the right-hand side, you can see a nice tree-map view, and this will present to you correlation of 2 metrics. So in this case, for the size, so actually how big is the square on this widget, they've assigned lines of code. So the bigger square there is on this widget, the bigger application this is in reality of the source code in terms of lines of code. And for the color, they have scale rating. So this is OK. I think not the most useful, but still OK. But imagine you could, for example, for the size, assign complexity, and then you will see which application in your portfolio or which module in your application is the most complex in terms of logic possession. And for the color, you can assign code coverage. And I bet that you will see those big squares which are super red because it's super hard to test complex logic. And then below, you can see evolution of 3 metrics. Line blue is lines of code. Line orange, I think, is duplicated lines. And green one is unit tests. So you can actually see evolution of certain metrics for projects from 2016 till from 2010 till 2016. As you can see, lines of code and duplicated lines equally grew because, of course, the projects got bigger and bigger. But interesting thing happened to unit tests. I guess there was a huge demand for unit tests between 2013 and 2014. But in 2015 and later 16, it looks like there was no need anymore to write unit tests. So this is really making your project transparent in terms of quality. This is the next view. It's called the hotspot view. Those are just some widgets which you can configure to examine your code base against any metric. In this case, this is hotspot by unit test duration, hotspot by highest complexity, duplications, untested lines, average method complexity, undocumented APIs. So this will actually create for you a nice list of priorities where you should at first take a look on in terms of certain metrics, like which modules, which files are violating a certain metric the most. Then you can take a look on issues view, and this will list for you all of the issues which were discovered by Sonar parsers, so software metrics under the hood. You can scroll down and scroll down and scroll down, and you can see what is going on with your application. Of course, you can filter by blockers, criticals, and majors. And you can later on, of course, configure those parsers to really focus on what you need, not to parse everything and not to look for everything. But this is a quite useful view. You have explanation. You can assign certain issue to somebody. And if you click on it, then you can actually see where is this living within your code. So you will be redirected to this certain file where this issue was found, even to this certain line of code. For example, here we can see that the issue says, refactor this code not to nest more than 3 if, for, while, try, and with statement. And we can see that this structure is not bad, but it's bit nested. So if you have time, perhaps you can think of this as assign a chore for a sprint or something like this. Also, there is information that it will take approximately 10 minutes to remove this technical debt to refactor this code. If you don't know what certain issue is about, you can click on it again, and you will see a nice explanation. What does this really mean to have nested code in your application, and how should you deal with nested code? So this is how it works, and the last view I would like to present to you is a quality gate. And quality gate is a set of metrics you can define by yourself with certain thresholds. And then you can apply such quality gate, for example, before a demo, before release after each iteration, or before huge release of your application. And you will be notified if the quality gate passed or failed. For example, if threshold for coverage is 80% and your code base has less than 80%, quality gate will fail, and you'll be notified about this. So you can encourage some best practices with those quality gates, and you can follow some really nice standards. In this case, you can see technical depth, coverage, duplications. There are a lot of more screens for SonarQube. This tool is extremely flexible. What's cool on the one hand, on the other hand, you really have to know what you're doing because you can easily get lost. So that's why this tool is more for technical people, I would say. All right, and now time for the second tool, Saline. This is the main dashboard of Saline, and you can already see, I guess, that this tool is for managers and business people because everywhere is productivity, governance, efficiency, etc. I will not talk about this in detail because this works more or less the same as SonarQube. So under the hood, there are some parsers based on metrics. They extract some data from your application. They do data mining, and they visualize this data in a nice way. So that's it about this dashboard because the real beauty is here. So this is what I like to call a software map. And software map is a one-to-one representation of your code base. Each single block on the map is a representation of each single file item in the reality of your source code. All of those islands, all of those squares, bigger and smaller, this is structure of your source code. So folders, subfolders, etc., etc. The real power of this metric, besides beautiful visualization, is that this really makes your project transparent in terms of quality. You can see what is going on with your project, and you can see if you need to react, or perhaps there's a bit more time. You can define some, actually everything is predefined. That's also quite nice because this is based on a few years of R&D. But it works like this, that you have some quality perspectives. In this case, this is productivity and complexity. And each quality perspective is examining your source code against 3 different metrics. At the bottom, you can see that 3 different metrics were assigned to 3 different dimensions on the map. For size, we have real lines of code. Its size is how big is this block on the map. So the bigger block on the map is, the more real lines of code are there within your file. For height, we have complexity. So the higher block on the map is, the more logic is stored there. So you can, just with those two metrics, for example, see if there are any big monolithic structures within your code base which are at the same time packed with logic. So this will be most probably a bottleneck. And for color, in this case, we have a metric extracted from version control system, because this is number of developers. And this will let you see, for example, if the file is not only huge monolithic structure, is packed with logic, but at the same time, many developers work there. So they basically step on each other's toes, right? So you'll be able to investigate where is real pain point of your application. So what should go first in terms of refactoring? You can configure those metrics to reveal, for example, places which are super complex. They possess a lot of nested lines of code, and at the same time, they are not tested by developers because, well, I guess it was hard to test code which is super nested. And then this is the way to make quality really transparent. So this is how it works. This tool is also quite flexible. There is no time to talk about everything, but it really gives you ability to prioritize your technical debt and to really address technical debt step by step. This is the last view I would like to present to you. Different perspective, because single block here is not a file item, but it's application. So it's a view on portfolio of applications. And for example, if you are a big insurance company and you have approximately 134 applications, this view will be quite useful for CIO or CTO. And those little things you can see, those icons on some blocks, those are watchdogs. Like you have a dog in front of your house which is barking whenever there is a thief. The same idea is here. So it's, I think, similar to quality gate. Those watchdogs will bark whenever a certain quality aspect is, for example, below a certain threshold. So that's it about the tools. And for the end of this presentation, if you find this interesting, I would like you to remember two things. First one is technical debt comes from decisions, not code. It's not about code, it's about those risky decisions we make because of something. And the question is if we want to address this later on or just leave those things undone. And the second thing is that technical debt is #1 impediment for teams really to be agile. Thank you.
Do those tools integrate well with continuous integration tools like Jenkins?
Sonar, yes, for sure. Sonar is super big and super flexible, so you can plug in Jenkins, you can plug in Travis, you can plug in GitHub notifications, etc. I think you can even create issues automatically in Jira from SonarQube. In terms of Serene, I think not, and I don't know if they want to go there. I think this tool is dedicated to managers, less technical people, and the aim of the tool is a bit different, so in terms of Serene, I don't think so.
Thank you. Very interesting. I have like a very basic question, I guess. What kind of company do you see actually using these tools? Because I can see that like an enthusiastic developer gets like, hey, let's install this SonarQube, like this software code base I'm working on is really bad. Let me just install that. Generates a bunch of graphs, massive amount of technical debt, and then what, right? Like who cares sufficiently about that to actually do something about it?
Mm-hmm. Okay, so before STX, I was a quality consultant for over 2 years in Germany, and my job was basically to go to a certain company, take source code from them, and do a quality audit. And I did this with Serene tool. Part of Serene tool was also integration of third-party tooling, and third-party tooling also included SonarQube. So out of approximately 30, 40 companies, 50% of them used SonarQube. And they extracted metrics from SonarQube in CSV format, and it was possible to fill in this data into Serene and actually visualize Sonar data on a software map. So this can tell you that 50% of companies in Germany use SonarQube. In terms of Poland, hard to say. I try to use this in Wrocław, for, first of all for myself, but I also do know that 2 teams took it over. And as a result, one team even created something what is called a technical retrospective. So besides the generic retrospective, during development, whenever anything is fine, they just put it on the list. And besides the normal retrospective, they also have technical retrospective to address those issues which were found during development. So in Poland, I think not many. In Germany, France, approximately 50%. This tool, by the way, was actually implemented in France.
Thanks, Łukasz. Really interesting presentation. As a product manager, I've got a question. What can I do with that data to brief my teams to build other than go refactor? And the second part to that question is how can I measure improvement based on essentially my decision? Because again, not just mine, but along with the team, we make these decisions whether to refactor or improve the code or not. But how can I measure that and ensure that we're delivering quality going forward?
Mm-hmm. Okay, so just to double check, the question is about if whatever you set to refactor was really refactored and your code improved.
Yeah, that's pretty much it. How do I actually track that measurement?
Okay, so with Saline, what you can see, for example, here on a dashboard are some nice charts with ongoing improvements, period of time, and this works more or less that you set a certain target. Some issues were found in terms of, for example, complexity or nested code. And because this was found, you as a manager can set up a target for the team to improve complexity by 10% till the end of the year, or to remove 40% of nested code for the next 2 iterations because there is no need for heavy business features, right? So there's time to refactor something. So you can actually set a target and you can observe how target is progressing because all of the time you measure. So the idea of those tools is to integrate them in CI. So for example, use them at the time of nightly build. They do a code snapshot and they parse code snapshot night after night. So you can really see what is going on and if your code improved or not, if the team really did what you said they should do. With SonarQube, this works the same. I don't know if this is visible here on, actually it is somehow because this orange area here, at the top you can see leak period last 30 days. So again, a certain time frame for some target, for some kind of improvements, and then you can observe if the job was really done or not. You can also use quality gates if your aim is to increase coverage of the code base because you discover that due to lack of testing you have some business troubles. You can define that, well, I would like to get to 85% till the end of the year, and then you can define also a quality gate and see if this aim was achieved or not.
How accurate are these metrics? Like what does it catch, what doesn't it? Like, would you blindly rely on the results of these metrics, or are there still many cases of terrible code that this tool wouldn't catch?
I think the key part here is that you have to understand and you have to know what to measure, because you can measure everything, and if you start to measure everything, then of course you will easily get lost because you will have, I don't know, 50,000 days of technical debt, and you just say, well, whatever, right? So you have to know where to start, but this really can help. In terms of those 5 metrics I showed before, so exactly those, you can use them separately and they will reveal nice quality aspects, but you can also combine them. With code leftovers, we did a quality check on insurance company. I cannot tell you the name, but it turned out they have approximately 2,000 lines of code out-commented, and that at the second stage, it turned out that those are unit tests. So basically, they deactivated unit tests, which of course before secured some implementation, most probably because those tests were failing and somebody said, hey, we have to go live. So this can really reveal quality issues. In terms of accuracy, I think this is very accurate because complexity, for example, this is McCabe complexity, so this will calculate amount of branch statements within your file module, etc. So how many if, for, while decisions you make within your file. In terms of code leftovers, you will see how many lines of code are out-commented, right? How many to-do statements are there in your code base? In terms of nesting level, this is extremely powerful. This will really let you see how many lines of code are there in your code base at nesting level 4, 5, 6, or deeper. And then you can, for example, make aim for the team. Hey guys, I know that this code is hard, so please at least try to cover this file, this code with tests. And as a nice side effect, you will receive refactoring because it's almost impossible to test code at nesting level 6 and 7. So it will be way easier for the developer to refactor the code, make it nesting level 3, and then test it.
Okay, but one thing that's probably hard to catch is like architectural over-design. Let's say that I have to write a program that splits a string into lines, and I come up with this massive, fully covered in unit tests, like class hierarchy of things that basically just cut up a string in like new lines, and that wouldn't appear, right? Like this because the code coverage is perfect, like the nesting is fine, not many if statements, no code duplication. I didn't comment out anything, so perfect score, I would guess. But still, like you're shooting a cannon at a mosquito, or whatever the expression is. But you know that kind of stuff probably wouldn't appear, right?
Yes, this for sure will not find everything, and I guess some of the things which are found by the tool won't make any sense. So this is not 100% accurate in terms of global view on the quality, but this can really help you to reveal where are the biggest pain points and where to start.
I think what you're saying is very true, that it's all about decisions, but generally speaking, not all code is equal. Like I might have particular features of my software that cover 99% of my most important business cases, and then I have a lot of stuff surrounding it. I might actually have 99% of my business cases covered and very well in terms of software metrics, but the other stuff is going to screw up the measures in a way. Is there any way to sort of weight basically parts of the software suite, parts of the code, to actually put the business value behind it into the consideration?
Mm-hmm. So if I understood the question correctly, it's not super useful in the case what you said, because of course in each single application, each single software, there is something not typical, something which is specific for your solution, and this can kill, for example, all of the measurements. So one way is just to skip this part of your code, same way as you can, for example, disable tests in a test framework. You can tell to Python, hey, just please disable this one for this run. You can do the same with the SonarQube. Or you can just, know about this and do not integrate those results from this module or this component or this piece of software into global results. So that's why I said it's quite important to know what you measure and how to read results, because you can easily misinterpret the results.
Thank you, Łukasz.
Thank you.